In section 2.1 we discussed relations, and in this section we're going to discuss functions. A function is just a special type of relation. So just like any other relation, it has a set of inputs and a set of outputs. But the thing that makes it specifically a function is that each input is paired with exactly one output. So let's look at some examples of functions and decide, or some examples of relations, and decide if they are functions or not. So we're going to illustrate a few of them with mapping notation here to start. So there's our set of inputs on the left. And there's our set of outputs on the right. And then the arrows are showing which input goes with which output. So when we look at a relation and we decide if it's a function or not, we're keeping that definition in mind, that it's a function if each input is paired with exactly one output. So if we look here, each input on the left is getting mapped to exactly one output on the right. So this one is a function. Here's another example. Here's our set of inputs. And there's our set of outputs. And then we'll draw in the arrows to show the mapping. So if we look at this relation and we look at each of the inputs, we can see that we have inputs that are going to more than one output. For example, the input of 1 is getting mapped to 2 different outputs. So that means this is not a function. Let's look at one last example here. So our inputs are that set of colors, and our outputs are primary and secondary. So we're going to map each color to the appropriate word, whether it's a primary or a secondary color. So let's determine if this relation is a function. So we're looking at each input and deciding if it's mapped to exactly one output. Well, the input of red is mapped to exactly one output. The input of orange is mapped to exactly one output. The input of yellow is mapped to exactly one output, and so on. Each input only has one arrow coming from it. So this is a function. So besides mapping notation, we can use a set of points to determine a relation. So let's say we have this relation. So the braces are just determining that we're writing down a set. And when we use a set of points to indicate a relation, we're showing each input paired with its output. So instead of using the arrows, we just write it as an ordered pair, input, comma, output. So just like before, we need to look carefully at our inputs. So an input of -2 is paired with an output of 5, and we don't see an input of -2 anywhere else being paired with a different number. Similarly, -1 is only being mapped to 2, 0 is only being mapped to 1, 1 is only being mapped to 2, and then 2 is only being mapped to 5. So this is a function. Let's look at this example. So in determining if this is a function or not, again, we're looking at the inputs, and here we see an input of -2 that is associated with 2 different outputs. So since we have an input that's being associated with 2 different outputs, this is not a function. Now, if we're thinking of our relation as a set of points, we can graph it in the coordinate plane. So let's graph each of these relations here, and we'll see if we can determine what's going to happen graphically for a function versus a relation that's not a function. All right, so here was our first relation. So we had point -2, 5, -1, 2, 0, 1, 1, 2, and 2, 5. So this is the graph of that relation. We don't connect the points because if we connect them, we're actually adding more points to the graph. For example, if I connect the point 0, 1 and the point 1, 2, I'm adding in points that have inputs that are numbers between 0 and 1, and we didn't have that in our relation. So these are the only 5 points in the relation, so those are the only 5 points that we plot. So this was the one that is a function. And then let's draw our relation that was not a function. So we had -4, 0, -2, 4, -2, 5, 0, 9, and 1, 5. And this one was not a function. So this second relation was not a function, we decided, because it has one input that is associated with 2 different outputs. It was the input of -2 that had 2 different outputs, one of 4 and one of 5. So those 2 points right there are the issue. So since they have the same input, they lie on the same vertical line. If we look at the graph that was a function, we don't have 2 points with the same input, therefore we don't have 2 points that would lie on the same vertical line. This is the only point on that vertical line, this is the only point on that vertical line, and so on. So using this criteria leads us to the vertical line test. So the vertical line test says that a graph represents a function if and only if every vertical line intersects the graph at most once. So you can look at it this way. If you can find a vertical line that goes through more than one point on the graph, it's not a function. If you can't find a vertical line that goes through more than one point, then the graph does represent a function. So let's illustrate using the vertical line test. So we'll draw some graphs. We'll draw the graphs and then we will decide which ones are functions and which ones are not. Okay, so we have a variety of graphs here. So let's use the vertical line test to determine which of these are functions and which ones are not. So again, we're looking to see if we can find a vertical line that would pass through multiple points on the graph. So if we look at the first one here, anywhere we draw a vertical line, it's only going to touch one point on the graph. So that shows us that each input only has one output. So this one is a function. Okay, if we look at the second one though, we can find a vertical line that passes through more than one point on the graph. So that's showing us that this input, whatever this x value is right here, has two different outputs associated with it. So this one is not a function. All right, for the third graph, anywhere we draw a vertical line, it goes through at most one point on the graph. So this one is a function. The fourth one down here, similar. Anywhere we draw a vertical line, it's only going to go through one point on the graph. So this one is a function. And the fifth one down here, we can find a vertical line that goes through more than one point. So this one is not a function.